I agree. I mean, it's being talked about in places that maybe even 2 or 3 years ago people didn't even think about it.
Oh, wouldn't have even acknowledged it. Yeah.
Wow, it's crazy. So anyway, let's talk about let's just start with number one.
Okay, what we've done is we've laid out a little threat matrix here in a little table, and we have across each row we have the threat, the level of the threat to humanity, how long it's going to take, is there any evidence to support it, what its current status is, and the potential impacts. And this is just a point of departure for further discussion within the report, but it also presents everything in a nice, concise way. So the very first thing at the top is what's known as the galactic superwave. And this concept has at its core the idea that energy pushed out of the middle of the galaxy pulses down through the ecliptic plane, which we're about to intersect with our solar system, and that energy pushes along with it vast quantities of dust. And two things occur. The heliosphere of the sun is smashed down by the energy levels being pushed out from the center of the galaxy, and dust accretes all around the sun, making it very dim and forming a hard shell, if you will. Then, of course, because the nature of the sun, the hard shell doesn't last very long, and it's shed in an explosive fashion that sends out a giant CME that scrubs off all life on the inner planets.
Right.
And this has some level of evidence support. Its level of threat is from extinction level down to mildly disruptive to civilization, depending on how much dust, how explosive, where the Earth is in its orbit, etc. The duration is relatively short. It's restricted to only a few months as we understand the concept, because the whole thing should happen over the course of essentially 1 year. There is supporting evidence for it in the ice cores for multiple impacts of galactic superwaves, especially within the iridium and rhodium layers laid down from space dust. So there is some level of support, and if ever there was going to be a particular point in time when our particular solar system was in alignment and could receive a galactic wave if it was coming out at us, that point in time is 2012. So the current status is that it may be underway, but we just don't know, and we won't know until we get there, because there's no way to detect the wave until it's on you.
Ah.
The superwave itself might be felt over the course of only a single day, and it might be on the order of a giant gamma ray burst, in which case it would seem as though light was coming from all parts of the sky simultaneously.
That's interesting.
Maybe to the point of actually superseding what the sun would present, and you wouldn't be able to see the sun.
Wow.
So an interesting set of problems arise with that, everything from satellite and EMP disruption to actual radiation poisoning. There would be infrastructure destruction if the dust was explosively expelled from the sun, so in such a manner as to present a giant CME that was actually Earth-touching.
Okay.
Set off forest fires, all that kind of thing.
Right. Okay.
Then we drop down to things like the solar cycle maximum. Even NASA is acknowledging that this is the case. It coincides with the late months of 2012. They are even worried about a CME, regardless of the galactic superwave, just about a coronal mass ejection that may cause us satellite problems and destroy our infrastructure. So even NASA is a little bit on the touchy side about this particular one. It could be extinction level event, but from their viewpoint, it would be probably more on the order of extremely disruptive to civilization, maybe some level of personal or population die-off, but an unknown quantity.
Okay.
Then a lot of the others here we have, like interplanetary climate change. This is underway now. If we don't put a cause to it and just deal with it as though it were a cause in and of itself, it could be, for instance, caused by the solar cycle maximum, or it could be caused by a precursor to the galactic superwave that we're just unaware of and can't detect. But if we just deal with it as a set of problems on its own, it alone is extinction level problem down to civilization ending. We have climate change on all of the planets now, including Mercury and many of the moons of the larger planets. So it is and the sun. So it's across our entire solar system, not deniable anymore. And it has nothing to do with who drove how many SUVs for how many years, or who burns coal or any of that.
Right.
Now, that indeed may exacerbate our particular set of problems here on Earth, but regardless of that, we still have huge potential problems coming from this climate change, which may also be just where we are in intergalactic space, and there's nothing we can do about it. It appears to be about a 100-year-long problem with a peak, of course, around 2012.
Uh-huh. Okay.
And then we have the Planet X. If it existed, it would be extinction level to mild disruption, depending on how far out it is. It's a long, multiple-century problem. We don't have any evidence to support it. The amount of data that comes on Planet X is sketchy, and the language is not self-referentially integrous, in the sense that there's contradictions in the original work that are multiplied and exacerbated through subsequent translations and transliterations. So the concept is out there, but there doesn't appear to be any reality to it.
Okay.
So we're just kind of dismissing Planet X as any kind of an issue. Now, again, if we eliminate all forms of cause and just deal with extinction events, we are currently in a mass extinction of species event. If we eliminate and don't even speculate as to what's causing it, we just have to acknowledge that this appears to be on track to be the 6th largest mass extinction event on this planet, and may include humans. We have no way of knowing if we're going to be in the group that survives or not. But we have to consider ourselves a large land mammal, and as such, the odds don't favor us.
Wow.
Yeah.
Not good.
Not good, no. And then we have, of course, the galactic center alignment. Now, we're using this as a linguistic proxy for alignment with the ecliptic plane of the Milky Way galaxy, because technically the alignment that is discussed in 2012 with the Dark Rift is only from the particular point of view of particular spots on Earth, and technically should not mean anything relative to the rest of the universe. In other words, really, does Alpha Centauri care what our view is of the galactic rift through the sun on a particular day? Really, the other stars and stuff are not affected by this particular alignment at all, and it exists only because of the precession of the equinox. However, coincident with the galactic alignment through the precession of the equinoxes on the December solstice of 2012, we will be in a situation where our solar system, 3.5 degrees wide astronomically, will be passing through the ecliptic plane of the Milky Way galaxy. And some of the planets that are in our solar system in their orbits have already done so, and we're about to reach that point in 2012 as well. So it is significant for Earth because we'll reach that point at 11:11 a.m. on December 21st, 2012, just as the Mayan long count suggested. And that means that the middle of the Earth would be in this band of what is hypothesized to be the collapsed magnetosphere of the whole Milky Way galaxy. Now, I know a long discussion there, but basically here's the deal. The Milky Way galaxy, when it started off, had a magnetosphere, a sphere of magnetic influence around it like a giant magnet, the way all objects in space do. And as the galaxy grew and grew and grew, the space between the magnetic field lines became such that they could no longer support themselves as a sphere, and they collapsed into like a thin plate-like structure. Make sense?
Yep, it does.
Okay, and we're about to pass through this condensed magnetic field line thing at the ecliptic plane of the galaxy. And there is evidence to support that the magnetic structures on Earth have been periodically disturbed, and that periodicity seems to align with some reliability with the precession of the equinoxes relative to the Great Year, which is our 26,000-year cycle, which includes these alignments with the ecliptic plane. And we've been on a predictable path of magnetic field destruction on the planet for the past 4,000 years that appears to have halted. We're very close to virtually no magnetosphere to speak of. We've seen the heliosphere of the sun collapse, and it may be that it's not collapsing internally, but a better way to think of it may be that it's being suppressed by a larger magnetic force from outside, which would really be the case if we were going through a magnetic ecliptic plane. Now, that again could be part of the superwave process. These things are all interrelated.
Right.
But if we just separate them all just for thinking about it, the magnetics alone at this particular point in space are not necessarily good for the continuation of things as they used to be.
Okay.
And then, of course, we have all the regular stuff like food crisis and collapse of the food crops and the economic system. But those are kind of like also ran, in my opinion.
Those are what?
And also ran, less of an issue.
Well, yeah.
They're there with everything, and,
Yeah, they're self-created.
Yeah.
Yeah, those are self-created stuff there. I mean, it's not like that kind of stuff wasn't known about before. So.
Correct. And actually, the food crisis and the economic situation are really the only things we can do anything about.
Right.
Which is why I keep coming back to, learn to grow fruit for pies and learn to make your own pie. And as far as the economy goes, you got pie. You can trade.
So if, as I'm looking at this table here that you have, the only question that I have here for you is I'm assuming some of these things, there can be more than one of these events that take place.
Oh, certainly. For instance, if we have a galactic superwave, it doesn't preclude the existence of the magnetic field we still have to go through,
right.
So we would suffer both sets of effects.
Right.
And in fact, all of them may include such things as, predictably, as the heating of the planet. And the heating of the planet would cause the glaciers to melt, which produce our global coastal phenomena, or super flooding, or whatever we want to think about. So it's all interrelated, and it's all going to produce things like nasty winds, nasty storms, a lot of flooding, food crisis, etc. And really, to some extent, at a certain level, the cause no longer becomes particularly relevant other than as a guess as to how long it might persist.
Well, and that would stand to reason that it is about what do we do, how do we take care of ourselves in the event of these.
Well, if we were a really smart species, we would organize ourselves as species around the predictable effects of this and not go into absolute academic denial over all of the strange catastrophic history of our species and planet. And so we've got ourselves into a quandary, because as long as we listen to academics, they're going to deny that catastrophism ever existed as a potential shifter of populations on the planet. They're going to deny the potential existence of the superwave or magnetic problems, in spite of the fact that we have all of the evidence in front of ourselves that the climate is changing and we're in severe distress ecologically. And so they're going to approach things from a different viewpoint and try and do reductionism as opposed to stepping back. But a smart species, for instance, might band together and build survival shelters that could survive going through a pole shift. Because you can calculate how much movement is likely to occur and the effects that are likely to occur, how hot the atmosphere is going to get, how much water is going to be displaced, because the quantities involved are relatively known. The mass of the crust versus the mass of the rest of the Earth, the rate of turn gives you the amount of friction, which tells you how hot the atmosphere is going to get. Plus, we have historical evidence that these pole shifts are not so fast that vast quantities of heat are given off. So in other words, the 30-degree pole shift that Hapgood discusses, if it occurred in anything faster than about 3 or 4 weeks, would produce a level of friction such that rock would melt and the atmosphere would go to about 2,000 degrees, effectively scrubbing the planet of any life. And we have no evidence in the past that such a thing ever occurred. Okay, so we know it's slower than that. And we can actually calculate how slow up to a certain point and realize that, hey, these things are survivable. And humans have survived them in the past, and the universe seems to favor us. Unfortunately, our current set of leaders, if you will, I really hate to use that term,
yes,
but our political elite and the academics and military that support them are not very good thinkers and are not thinking in a species way. They're all into the love of power and personal aggrandizement and have a very short-term view and are not really looking at what does humanity need.
Well, that's true, because they don't put it in the same category, unfortunately.
Right.
Now, I said I wasn't going to take any questions, but this is directly related to what we were just talking about.
Sure.
Somebody in my chat box has asked if you are sure about passing through the galactic plane, because they've seen credible YouTube videos that show we're about 30 million years away from the equatorial plate of the Milky Way.
Yeah, okay, and I too have seen this evidence that's been presented. And the issue is, it's actually threefold, but we only need to care about two of the issues involved. The ecliptic plane, insofar as we're discussing this, is very wide. And our solar system is 3.5 degrees wide astronomically. And the ecliptic plane can be thought of as being about 7 times in its